Okay, we'll start the lesson now. Everyone can hear me?
It's only me though.
Oh, wait, just now Casper joined for a while. Where did she go?
Wait, how many students are we supposed to have in class?
Today only supposed to have two, I think.
Oh, okay. Oh, also, I've been really busy this past week, so I didn't get the chance to look at it yet.
It's okay. I will go through like summary before we go through the questions.
Oh, okay. Also, my school just went through like what we went through last week today.
The experimental techniques. So can
Yeah,
I
like the photograph and all those.
about my number, right? Actually, because like I don't work under 88. I don't know how to explain, but
Oh,
I like they kind of outsource some
okay,
businesses.
okay.
Yeah, so I'm not sure whether I'm supposed to leave out my number.
Oh, okay.
But if you have any questions, right, there is like not from like the worksheet from A, right? You can ask me during class also.
Oh, okay, okay.
Hello, Casper. Can you hear me? We'll start class now. Okay. So today we are actually going through the chapter on kinetic particle theory. Okay. So before we go through the questions, I will just do a quick recap or quick summary of the main points of this chapter lah. Okay, so for kinetic particle theory, is actually talking about the three states of matter. Okay, so in solids, right, the particles look like this. So what we can say about these solid particles is that they are in a fixed regular pattern. Okay, so this one is solid. And then we have liquid also. So there is no fixed regular pattern here. Then lastly, we have the gas. The particles will look like this. So the particles are free to move. Okay, so we know that for solid and liquid, these two states, the volume is fixed. Like if you have something solid or you have like water, liquid, right, you cannot compress it and change its volume, right? But for gas, there is no fixed volume because we can compress gas. And then when we look at the solid, it's fixed in this regular pattern. So the only movement it can do is to vibrate about its fixed position. And then for the liquid, they can move a bit. They are able to slide over one another. And then for the gas, they move rapidly and randomly in all directions. So for the solid, we also see that the particles are very near each other, they are packed very closely. So we also say that they have very strong intermolecular forces of attraction. Then for the liquid, even though they are not in regular patterns, but they are still close together. So the intermolecular forces of attraction are still reasonably strong. And then for the gas, they are far apart, so there are weak intermolecular forces of attraction. Okay. And then when we talk about the three states of matter, we also have to talk about the interconversion, right? So this one you all should be familiar. To convert from solid to liquid, this one is called melting. To go from liquid to gas. Oh, okay, sure. Oh, but actually these slides will be uploaded on the ADA website also after the class. Okay, and then this one is called boiling. So the opposite way will be called freezing. And then from gas to liquid, this one is called condensation. Okay, and then last week, during our experimental techniques class, we went through a special change of state where we go from solid to gas, right? Anyone remember what is this state called? Sorry, what is this process called? Starts with a S. Okay, so if you all don't remember, it's called sublimation. So sublimation is a method. Recall from your last chapter, we can use it to separate substances. So again, the examples is iodine and dry ice. Okay. Okay, then moving on to the next part, we have the heating and cooling curves. Okay, so heating curve looks like this. On our y-axis, we have temperature. The x-axis, we have time. And then as we heat something up, this is how the temperature usually changes with time. Okay, so over here, we say that the substance is in solid state. And then as it get heated up, over here, it reaches its melting point. And then after that, it will melt and become a liquid, right? So here we can say that the substance is in liquid state. And then again, it just keeps gaining heat as we heat it. And then after that, it will reach the boiling point. Then after it boils, it will change state to become a gas. So why is there this area where the temperature is constant? Okay, so what is happening here is that heat is absorbed uh, the temperature remains constant because the heat that is being absorbed is being used to overcome the forces of attraction between particles. So, as you saw earlier, the solid have very strong forces of attraction. So, in order to change state from solid to liquid or liquid to gas, we need to overcome the forces of attraction so that the particles can move further apart. So, the heat is being used to overcome the forces of attraction. Okay, and then at this area, right, we will say that there is a mixture of solid and liquid. So some of the solid haven't melt finish yet. Only at this point over here, then we can say that everything is a liquid. Then when the temperature start rising, then we know that everything is a liquid. Then over here, similarly, it is a mixture of liquid and gas, because not all the liquid has finished boiling off yet. Okay, so for this is called the heating curve. So the cooling curve will look the same, just that it's like the temperature is going down instead. So similarly, here we have the gas, and then here it is undergoing condensation. So now we have liquid here, and then over here is undergoing freezing. And then over here, we have solid. Okay, so the last part of this chapter is something called diffusion. This one, Shina, you don't need to know. It's not in your syllabus. Okay, so what is the definition of diffusion? It is the net movement of particles from a high concentration region to a low concentration region until equal concentration is obtained.